Let's continue section 2.1, day 2. So we want to graph the following: x cubed minus 12x. First of all, the name of the function is the cubic function because of the 3, it's cubed. The degree is 3. The leading coefficient is 1. So it's an odd degree with a positive leading coefficient. So they're going to go different ways, but they're going to match what's here. So it'll look like that, down on the left, up on the right. So as x goes to negative infinity, as we go left, f of x goes, down. So that's negative infinity. As x goes to the right, or to positive infinity, which is the right, f of x, or y, goes up, so it's positive infinity. So that's great. But let's get our Desmos on so that we can graph this function, because that's not a very nice function. I don't know the values offhand, so we have to do this. So we do this. Of course, we do the gear and the table. And now, zoom out a little bit. We probably want these points. The turning points, the center point, and then these other extra points just to make it look good. So let's graph those points. -2, 16, -1, 11, 0, 0, 1, -11, that would be here, and 2, -16. But then look what it does after that. So it's coming from down here. It hits this point, that's our turning point, then it goes back down, then it hits our other turning point, and that goes up. And that's fine, that's good enough for us. We have some nasty kind of where it intersects, it's -3.4, we'll say -3.5, and 3.5 as our x-intercepts, and of course 0. Now we have enough. Let's answer the rest of these questions. The domain. Well, as we go left, it keeps going on for forever, and as we go right, it keeps going on for forever. Negative infinity to positive infinity. The range, well, it keeps going down, and it keeps going up for forever. So it too is negative infinity to positive infinity. Our x-intercepts, right there, there, and there that we marked, are not very good. But we saw it on the graph. It was -3.5, 0, give or take, 3.5, 0, and 0, 0. 3 x-intercepts, but only one y-intercept, 0, 0. The origin is an x-intercept and a y-intercept. All right, interval of increase. So increase, we're increasing, then we're increasing again here. We have 2 parts where we're increasing. First one starts at negative infinity, it's all the way to the left, and it stops right at the top here at -2. Remember, we use the x values. Then union, or and it starts happening here again at 2. It starts increasing, and it goes on for forever. So negative infinity to -2, and 2 to infinity, just like we did last chapter. Now, obviously, then, it's decreasing in between that. So it would be decreasing from the top here, the x value, -2, and it'll keep going to the bottom value, +2, x values. That's our decrease interval. See if I can erase just a little bit. There we go. Good. Now we'll talk about positive, negative. That's the next step. So our positive intervals was this little part and this going on for forever. Negative is this little part and this little part. So we're going to have 2 parts for each of these. Zoom out so we can see our positive, negative. So it's positive in the yellow. It starts at -3.5 approximately, right there, right there. And it's positive, 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 positive all the way down to 0. Union, it picks back up at 3.5, and then it keeps going on for forever, so infinity. Now for negative, it's the blue. So it starts off negative infinity because it came from way to the left, and it stops at -3.5. Union, and then the other blue part, which starts at 0 and stops at 3.5. We got our negative interval. The last thing for this problem that we need to do is we need to find the average rate of change on -2 to 0. Now these are both x values. So -2, comma something, and 0, comma something. And we're just going to find the slope on that. So if we go -2 on our x, we get a y of 16. That was our point. And 0, 0 was our point. So we just do our y2 minus y1 over x2 minus x1. So we can let this be x1 and y1. This is x2 and y2. Doesn't matter which is which. So 0 minus 16 over 0 minus a -2. Well, 0 minus 16 is -16. 0 minus a -2 is really 0 plus 2. -16 divided by 2, we get -8. And that is our average rate of change between -2 and 0. All right, we got another one, but now we got it graphed for us. We'll do the same thing. Then we got a word problem, and then we'll call it a day. So graph the following. Well, it's already there. Name of the function. This is a quartic, meaning 4th degree, because it's to the 4th power. Pretty straightforward. The degree would be 4. Again, we're looking at this first term, and the leading coefficient is -0.5. So we have an even degree and an negative leading coefficient. But we can see the end behavior. It's going down on both the left and the right. So as x goes to -infinity, or the left, f of x goes down to -infinity. As x goes to +infinity, to the right, f of x goes to, or goes down as well, to -infinity. They're both the same. Whenever it's an even degree, they're both going to be the same. Our domain. Well, this goes down on the left, and it keeps going to the left for forever. It keeps going to the right for forever. So our domain is negative infinity to infinity, or are all real numbers. However, the range is not all real numbers this time. Now we're going all the way down. We don't have a lowest y value, so it's got to be negative infinity. And we do have a highest y value. And they're both the same, actually. There's those two little humps. We got a y value of 6.5. So that would be our range. Actually, it would be a square bracket because there is a point at 6.5 because that's what we're using. So that's our domain and range. The x-intercepts, negative 2.57 comma 0 and 2.57 comma 0. Just these 2 points. They're not necessarily nice numbers, but they work. The y-intercept is right here in the middle, and that would be 0, 2. Make sure they're ordered pairs, not just one number. Our increasing interval. Increasing here, up. Then we're increasing here, up. So it's just those two parts. So our increasing interval, the first one, this first yellow section, starts at all the way on the left, so negative infinity. And it goes all the way up until the peak here, and that's negative 1.73. Union, we have the other part here. It starts at x equals 0. So we want the x value. And it goes up to the second peak, 1.73. Again, we want the x value. Our decreasing interval, of course, would be everything else. That little snippet, and then this part that goes on for forever. So our decreasing interval, the first one, starts at x equals negative 1.73, and it goes to the middle there at 0. Union. And then it's decreasing after the second hump, so that's 1.73, and it goes on for forever. It keeps going to the right, so it's positive infinity. That's our increasing and decreasing. Do this again. That graph's already there. All right. Now, positive, negative intervals. Positive is just that. Negative are the two outsides, really the two end behaviors. So it's positive in the yellow, which starts here. So at negative 2.57, positive, 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 up. And at 2.57, it starts becoming negative again. So it's negative 2.57, comma 2.57. The negative interval would be the two blue parts here. So this first one starts all the way on the left, negative infinity, because we can't see where it starts, and it stops at negative 2.57, where the yellow starts. Union. Similarly, the second blue section starts at 2.57, but then it keeps going to the right for forever, so it's positive infinity. So not nice numbers, but same idea that we've been dealing with. So our average rate of change is just like what we did in the last problem. The 0 and the 2 are x values. So x1 is 0, x2 is 2. And then to get our y values, we look at our graph. Well, at x equals 0, y is 2. That's our y-intercept. At x equals 2, we go up. We can see that that's right at y equals 6. So that's our point. That's x1, y1, x2, y2. So we do y2 minus y1 over x2 minus x1. 6 minus 2 is 4. 2 minus 0 is 2. And 4 divided by 2 is 2 as well. That is our average rate of change from 0 to 2. Now, we have this word problem. The profit margin of your new company can be modeled by P of X or Y. So that's our profit, equals negative 2x to the fourth plus 8x cubed, where X is the number of units sold, and the profit is in millions. So what will your profit be if you sell 2,500,000 units, or an X equals 2.5? Well, very simply, put it in decimals, and you can just type in your 2.5, and that's what our Y value is. But that's in millions, so that's 46,875,000 units. Or, sorry, dollars. A lot of good stuff there. Our x-intercept are 0, 0, and 4, 0, and our y-intercept is 0, 0. So this means that y, which is our profit, equals $0. So if we sell 0, or we sell 4 units, we'll make $0. And that kind of stinks. Or I guess that would be, no, that would be fine. There are break-even points where we don't make any money. The profit is 0. The y-intercept is again the same thing. If we sell 0 units, we get $0. That's the end of 2.1 day 2.